Imagine discovering something so strange that it forces scientists to question decades of research. That is exactly what happened when astronomers looked deep into the universe and found gigantic black holes that seemed impossible. Not impossible because black holes don't exist. Impossible because they appeared far too early in the universe's history. According to many scientific models, there simply wasn't enough time for them to grow that large. So how did they get there? To understand the mystery, we first need to travel billions of years into the past. It may sound impossible, but every time astronomers point a telescope into deep space, they are actually looking back in time. Light doesn't travel instantly, it moves at an incredible speed, about 300,000 kilometers every second, but the universe is so vast that even light takes billions of years to cross it. That means when a telescope detects light from a distant galaxy, it isn't seeing that galaxy as it is today, it's seeing it as it was billions of years ago. In a way, the universe has preserved its own history in light. The farther we look, the younger the universe becomes. When astronomers used powerful telescopes to explore this ancient universe, they expected to find small galaxies, young stars, and relatively tiny black holes that were only beginning to grow. Instead, they found monsters. Some of these black holes already contained millions, and even billions, of times the mass of our Sun. That discovery stunned astronomers. Because according to many of our current ideas about how black holes form, objects that massive should have needed far more time to grow. Yet somehow, they were already there. It was like finding a fully grown forest only days after planting the first seed. The question was no longer whether these black holes existed. The question was, how did they grow so quickly? To understand why this discovery is so surprising, we first need to understand how black holes grow. Most black holes begin their lives in a violent way. When a massive star reaches the end of its life, it can collapse under its own gravity, creating a black hole. But these newborn black holes are not instantly enormous. They need time to grow. They become larger by pulling in gas, dust, and sometimes even entire stars. Some can also grow by merging with other black holes. Over millions or even billions of years, these processes can transform small black holes into some of the most powerful objects in the universe. But this creates a problem. The early universe did not have billions of years. The black holes astronomers discovered were already incredibly massive, when the universe itself was still very young. It's like planting a tiny seed, and returning only a short time later to find a tree taller than a skyscraper. You wouldn't just be surprised. You would start questioning whether your understanding of how trees grow was incomplete. Astronomers faced a similar problem. These ancient black holes were not breaking the laws of physics, but they were challenging the way scientists thought black holes formed and grew in the early universe. Did these black holes start from something much larger than we expected? Did they grow at a speed we haven't fully understood? Or is there something about the early universe that we are still missing? Scientists began searching for answers, and several possible explanations started to emerge. One possibility is that these black holes had a much larger beginning than scientists originally expected. Instead of forming from the collapse of a single star, they may have formed directly from enormous clouds of gas, collapsing under their own gravity. If that happened, they would have started with a much bigger advantage, allowing them to become massive much faster. Another possibility is that some black holes in the early universe were surrounded by enormous amounts of material. With enough gas available, they could have continued feeding and growing at an incredible rate. There is also another possibility. Maybe our current understanding of the early universe is incomplete. Science is not about protecting old ideas. It is about testing them against new evidence. When discoveries don't match predictions, scientists don't see it as failure. They see it as an opportunity to learn something new. These ancient black holes are more than just strange objects floating through space. They are clues. Clues that could help scientists understand how the first galaxies formed, how the universe changed over time, and whether there are parts of cosmic history we still don't fully understand. The truth is, we still don't know exactly how these enormous black holes formed so quickly. And that is what makes them fascinating. Some of the greatest discoveries in history began with a mystery that nobody could explain. Every time humanity believes it has uncovered the secrets of the universe, something new appears and reminds us how much we still have to learn. These black holes may be another one of those moments. Because the universe does not just give us answers. Sometimes, it gives us better questions. And somewhere, hidden in the darkness of space, there are still mysteries waiting to be discovered.